There are three types of chemical formulas: molecular, empirical, and structural formula. But how they differ with each other? Well, let us find out. Molecular formula is sometimes called the true formula because it tells us the actual number of different elements in one molecule of a compound. This is the molecular formula of glucose. It is the type of sugar you get from foods you eat and your body uses for energy. Empirical formula, on the other hand, is the simplest ratio of real numbers of elements that make up a compound. Just like how you simplify fraction in mathematics, you do the same in molecular formula. So this is the empirical formula of glucose. The structural formula shows both the actual number of atoms of elements in a compound and how the atoms are arranged and which atoms are bonded to one another. Here is the molecular formula for glucose, the empirical formula for glucose, and now the structural formula for glucose. We finally reached our discussion for the atomic mass. As we discuss the periodic table, we are now going to find out how the atomic mass are calculated. The periodic table only tells us the weighted average the atomic masses of different isotopes for an element. But how do they calculate the weighted average of atomic mass? We now need to understand about the isotopic abundance. We know from previous discussion that elements have different isotopes, and these isotopes of a given element do not all exist in equal ratios. Let us take for example the element mercury, that has 7 naturally occurring isotopes. As we learned before, isotopes of the same elements have different atomic mass units. This is because it has different number of neutrons in its atoms. So in order to calculate the weighted average of atomic masses, we need to consider the percent abundance. On the second part of our discussion about atomic mass, we are going to show how the atomic mass of a particular element has been calculated. As an example, let us consider the element carbon. First, its isotope carbon-12 that has an atomic mass of exactly 12. Carbon-12 is 98.89% abundant in nature. Another isotope of carbon is carbon-13 with 13.00335 atomic mass unit. Carbon-13 is 1.11% abundant in nature. In calculating the average atomic mass, we need to multiply it to the isotopic abundance. On this example, we will multiply the atomic mass unit of carbon-12 to its percent abundance. We are going to add it to carbon-13 atomic mass unit multiplied to its isotopic abundance. The answer will give us 12.01 atomic mass unit, and this is the average mass of carbon. This is the first part of our discussion about atomic mass unit or AMU. Atoms are too small to be weighed on even the most sensitive balance. A relative scale has been set up comparing the masses of atoms. It was agreed to use one isotope called carbon-12, which is assigned a mass of exactly 12 atomic mass units. Atomic mass unit by definition is 1/12 of the mass of carbon-12 atoms. We use an equipment called the mass spectrometer in order to determine the masses of other atoms relative to the value of 12 AMU for carbon-12. In this device, a beam of gaseous ions separates into components of differing mass as it passes through the electric and magnetic fields. The separated ions are focused on measuring instrument which records their presence and amount. Here is now the second part of our discussion about atomic mass unit or AMU. We have learned that carbon-12 has an assigned value of 12 AMU. Please take note that even though mass numbers are whole numbers, actual masses of individual atoms are not exactly a whole number, except for carbon-12. On this scale, hydrogen is almost equal to 1 AMU and oxygen is almost equal to 16 AMU. In order to determine the atomic weight, we need to learn the weight of each subatomic particle composing an atom. The positively charged proton is equal to 1.0073 AMU, neutron is equal to 1.0087 AMU, and the negatively charged electron is equal to 0.00055 AMU. Take note that the weight of the electron is much smaller compared to proton and neutron. That is why it is considered negligible when calculating the atomic weight. Here is the third part of our discussion about the atomic mass unit. We have shown the equivalent atomic mass unit of each subatomic particle, the proton, the neutron, and the electron. We also highlighted that the atomic mass unit of electron is much smaller compared to the proton and neutron. That is why it is considered negligible in calculation. But how do you calculate the atomic mass? Have a look at this example for the helium atom. It contains 2 protons, 2 neutrons, and 2 electrons. Looking back on its equivalent atomic mass unit, we are going to calculate the atomic mass. 2 protons times its atomic mass unit, 2 neutrons times its atomic mass unit, and 2 electrons times its atomic mass units, which is equivalent to 4.0331 atomic mass unit. Who is Amedeo Avogadro? Amedeo Avogadro is an Italian scientist most noted for his contribution to molecular theory, now known as the Avogadro's law. He was born in Turin, Italy on August 9, 1773. This constant is named after him. This is the Avogadro's constant. It indicates the number of atoms or molecules in a mole of any substance. You can see that it's written in scientific notation indicating a very large number. It is because a mole of a substance or an element is composed of a very large number of atom or molecule. If we write it in the number form, it will look like this. But how do we use the Avogadro's number? That's what we're going to discuss in the next videos.